Hello! I'm working on a game called Dungeon Master using Godot, and in it I use 3D sprites that the player can hover with their mouse and click on. Today I'm going to be showing you how to do this and detect mouse inputs on 3D sprites with transparency in Godot. We're going to start out with a new scene. We're going to make this a Sprite3D. We're going to set the texture to this little night texture I have here. And then we're going to add an area 3D as a child of this, and a collision shape 3D as a child of that. We're going to set the shape to a box shape. We're going to make the Z have 0 thickness so it's nice and flat alongside our sprites. Next, we're going to set the collision layers that we're going to work on for our mouse input. For the sake of this, I'm just going to leave it as layer 1, but in a bigger project, you want to make sure you set this so that you're not interrupting other inputs. Then we're just going to add a script to our sprite. All right, here we have the script for our sprite. We have 3 signals here for input event, mouse entered, and mouse exited. These are the same signals you would see on a control node, and we're going to make them do the same thing. We have 2 variables, mouse over, which is going to tell us whether the mouse is over, and the image, which is going to be image data of the texture on this sprite. Next, we call an onReady variable to get our collision shape. And lastly, we have a variable for whether we received a mouse input on this frame. To start with, we're going to look at this function of onTextureChanged. We are going to bind this to the texture change signal of the sprite that's built in. First thing we're going to do is we're going to save the texture.getImage to the image. We're only going to do this when the texture is changed because this is an expensive function, and if we call it very often, if we call it once per frame, we're going to have performance issues. Next, if you're using Godot 4.2 or later, you're going to want to add this bit of code. This will decompress your image so that you can get the pixel data on it later. Lastly, what we're going to do is update our collision shape. We're going to call collision shape.shape.size.x and set that to the texture width times the pixel size, and we're going to do the same for the y. Here I've defined some basic on mouse entered and on mouse exit signals just so that we have something going on when these signals take place. Next, we have a function called try mouse input. This takes a lot of variables, but it's pretty straightforward. These are all the things that the input event signal normally emits. So we're just going to make sure we take them from our camera later on. On try mouse input, we're going to say that we received a mouse input, we're going to fire the input event signal, and we're going to return true. Lastly, we have a function for on 3D mouse ray processed. This is going to be called every frame after the camera processes the mouse input. If we received a mouse input and the mouse was not over, that means that the mouse is entered, mouse over is true, and we're going to fire mouse entered. Otherwise, if we did not receive an input and the mouse is currently over, that means the mouse is exited, we're going to set mouse over to false, and we're going to fire mouse exited. And lastly, we're going to set mouse input received back to false. The last thing you're going to want to do is make sure you connect your signals back to your script. So on texture changed goes to on texture changed. Mouse entered goes to on mouse entered. Mouse exited goes to on mouse exited. Save that. And in a new scene, we're going to add our Sprite3D. And we're going to add our camera to the scene. We're going to drag this camera back so that it has a nice view of our sprite. Perfect. And we're going to add a script to this camera. Here in our camera script, we've defined a constant for the ray length. This is going to be the length of our raycast from our mouse position. You're going to want to make sure this has a finite distance, otherwise your raycast will go forever, and that can cause performance issues. If you're having problems with not picking up faraway objects, you can always make this bigger or smaller depending on your needs. Next, we have our mouse ray process signal. And here I have a 3D physics layer export. In editor, this will give us a set of physics layers which we can use and then pass to our raycast to pick our layers that our sprites are on. Now we have two variables, query mouse and mouse event. This is going to say whether we need to check our mouse. This is going to store the event that our mouse fired. First things first, we have the built-in unhandled input function. Here we're going to take any event that is a mouse event. We're going to say query mouse is true, and we're going to save that event locally. Next, in our physics process, you could also do this on regular process. If we are to query our mouse, we're going to call check sprite input, and we're going to say query mouse is false, and we're going to emit our mouse ray processed. Next, we have our check sprite input function. First thing we're going to do is make an empty list, and this is going to store all of our unsuccessful hits for our sprites. Next, we're going to declare some complicated looking but pretty straightforward boilerplate. This is just the parameters for our raycast. We have our space state. This is getWorld3D.direct space state. We have a from position, which is going to be the project ray origin of our mouse event dot position, and 2, which is from plus the ray normal of our mouse event position times the ray length. Then we are going to iterate until there are either no more sprites that our ray collides with, or we get a successful sprite and then we return. So while true, scary I know, we're going to define a physics ray query 3D, created with our from, our to, our sprite layers we exported, and we are going to exclude the list of not hits. Then we are going to set collide with areas to true. We're going to save the result as space state.intersect ray query. This is going to give us a list of areas which our ray has collided with. If result is empty, exit, and we're going to return false. Otherwise, we have collided with a sprite. We're going to call result.collider.owner. This is going to get the actual sprite itself versus the area. We're going to call the try mouse input function we got earlier, passing on self as the camera, the mouse event as the mouse event, our position of our result, and our normal as the result. If try mouse input returns true, we are going to exit. Otherwise, we are going to append that sprite to our list of not hits, and we're going to go through the loop again. This return true will never actually happen, but Godot needs it to be there so that every path technically has a return state. Lastly, back in our Sprite script, we are going to add a ready function. The first thing we're going to do is take the shape of our collision shape, and we're going to set that to a duplicate of itself so that each instance of our sprite has a unique shape. Otherwise, when you change the shape on multiple instances, it'll have the same shape for all of them and they won't line up. After that, we're going to call our onTextureChanged function so that we update the collision shape and we get our image. And the last thing we're going to do is get our camera by calling getViewport.getCamera3D. And if that camera has our mouse ray process signal, you're going to connect that signal to our on3D mouse ray process function. Now back in Godot, you're going to want to make sure you set the correct sprite layers on your camera script. In our case, that is layer 1. And if we run this scene, we should see that the sprite is getting our mouse over and it is doing what we told it to do, which is turn red. Now, you'll notice this is getting the entire area of the sprite and it is including the transparent areas. We don't want that. So back in our sprite script, we are going to make some changes to the try mouse input function. Instead of always returning true, we are going to ask, is this pixel opaque? We're going to pass the input position, and if it is, we're going to do what we normally did and return true. Otherwise, we return false, and our camera will go to the next sprite and try that instead. Our isPixelOpaque function, this implements the same behavior as what already exists in 2D sprites, but we're going to do it in 3D. So the first thing we do is take a vector 3, and we're going to convert that to a pixel on our sprite by getting the input position, which is in world space, minus our global position, and dividing it by the pixel size times our scale. Next, we get a local X and Y coordinate for our texture. Because the image is centered, we're going to add half the width to our pixel position.x, and for our Y coordinate, because 2D images use an inverted Y direction as 3D space, we actually have to subtract the same function from our original height. This will give us the correct Y value for our pixel. Lastly, we call image.getPixel. We pass our local x and y, and we compare the .a, which is the alpha of that pixel, aka the transparency, and we say if it is greater than 0, aka if it has some opacity to it, we're going to return true. Now, you could export a variable, a range, which is your transparency tolerance, if you had, say, an image that had partial transparency that you didn't want to include. But for the sake of this project, it is good if we just leave it at 0. Our scene, and we run it again. Our sprite picks up the mouse input, it does what we want it to do, and it works with transparency. This effect will work on any camera angle, and it will work with multiple sprites overlapping one another. And that's it. You'll find a link to the source code and my game Dungeon Master down in the description. Please leave a like and comment if you found the video helpful, and let me know if there's any other Godot topics you want me to cover.